time to time, they need to go to sick bay, where the doctor diagnoses them by utilizing this handheld device that provides them with the capability of scanning their body and knowing everything about their pathology. So this, to me, summarizes what we want to do, at least in the rehab area, because what we envision is that in the future, by relying on wearable technology, we will be able to download data from wearable technology that's sitting on patients and therefore know what's actually happening in the home and community settings. And as you will appreciate in a few minutes, there are applications in which this is very important because patients, they don't have an objective perception of their motor status, and therefore you can't really assess these through the interview or the examination of patients because these are patients whose condition evolves very quickly over time. And I'll provide a couple of examples in this area. So what do we do in rehabilitation with this technology? Well, we do really essentially three major things, and we organize, in fact, both conceptually as well as for the purpose of illustrating our projects to other people. We divide our projects into three large categories. One in which we do essentially what people have tried to do in the past with pedometers, but in a slightly more sophisticated way. We identify activities that are performed by patients. The second area of projects that we're running is one in which we often say in a provocative way, what patients do is really none of our business. What we care for is the quality of movements that are associated with certain tasks, because motor disorders are associated with changes in the movement patterns, and therefore by looking at changes over time in these movement patterns, you can appreciate the severity of the disease and adjust interventions accordingly. And the third area, which I think is coming up very strongly, is one in which we use this technology to feed back to devices that are typically mobility-assisted devices or things that are utilized in motor retraining of individuals, where the use of wearable allows us to extend the use of the devices outside of the clinical setting and also to deliver motor retraining techniques that are a lot more sophisticated than we will be able to do otherwise. So in the first area of projects, which I'm not going to describe just for the sake of time, as I mentioned, we are interested in identifying essentially the motor tasks that people are engaged into. One example is the one illustrated in this slide, in which we are monitoring activities in patients with chronic obstructive pulmonary disease. This is a project that we managed actually to get sponsored by Intel, just for the sake of disclosure. We're not interested necessarily in, as I mentioned before, implementing a sophisticated pedometer, but rather we're interested in identifying activities that are performed by people, by patients in the home and community settings, and at the same time track systemic responses that are associated with these activities and analyze trends as they occur over time. So the objective essentially is the one of identifying changes in systemic responses that are associated with equally demanding motor tasks. So let's say a patient is going up and down a flight of stairs, right? And we look at respiratory rate, oxygen saturation, and heart rate. And we want to see if that's actually changing over time. Why is that important? Well, it's important because the major problem that you have in the management of these patient population is the one of managing exacerbation episodes. And for those of you who are not familiar with this disease, what patients do, they actually have fairly stable status for relatively long periods of times, and then they have exacerbation episodes by which they drop significantly, and unfortunately they never come back. And so what you do when an exacerbation episode occurs is that if it's a serious, it's an actual exacerbation episode, you hospitalize patients, you are very aggressive pharmacologically, which you can be all the time because of the side effects of medications. And unfortunately, although you do that, although you intervene very aggressively, you don't bring the patient back, which is the reason why, unfortunately, the great majority of these patients, they never make it to a lung transplantation. And so, again, these are series of projects, and this is just an example in which we are identifying activities, and in this specific one, we're interested in identifying activities because systemic responses that are associated with them, we believe, or at least we hypothesize at this point in time, could lead to predicting exacerbation episodes in these individuals. There are lots of problems with sensing technology that I'm actually not discussing at this point in time. I'm just focusing on applications of these technologies because I assume there will be plenty of talks during the conference on problems that you have gathering this physiological data. In a second group of projects, we focus on quality of movements in these individuals. This is for the purpose essentially of, number one, assessing the effectiveness of interventions. And the video clip that you see on the right side of the screen is one of these examples in which we're having a patient's performing activities in the lab. Again, this is a pretty old video clip in which we use actually ambulatory technology. And this is, believe it or not, is part actually of a formal test, which is the Wolf Motor Function Test, one in which you ask patients to perform a number of activities that are activities of daily living. And you have criteria to assess quality of movements. This is a project that we got sponsored by NICHD, which is one of the institutes of NIH in the US. The reason, I guess, why the reviewers got excited about this is because through wearable technology, what we do in this case is that we predict clinical scores that are associated with these patterns of recovery. And by achieving this goal, what we can do in the long run is monitoring patients in the home settings, figure out the way they are responding to certain interventions, and adjust them if the response is not the expected one. So category number two, it's one in which, as I said, we look into movement patterns, characteristics of movement patterns that are associated with quality of movements. And as I just mentioned, number one application is the one of monitoring changes over time that are associated with interventions. And the other application is medication adjustments and, or titration. And I'll actually provide you a bit more of a detailed example in this area, and therefore I'm not going to comment upon it at this point in time. The third area, which I think is pretty much exploding, at least in rehab engineering at this point in time, is the one in which we utilize sensing technology to improve the functioning, quote unquote, of devices that might be robotic braces, of robotic system, or prosthetic devices. They do require a lot more information that what you can infer on the basis of sensing that's actually sitting on the device itself. And I'll provide some examples in this area as well. So I'll focus, as I mentioned, on these latter two categories of projects. And I would like to present you with an example of the second one, which is work that we got funded by NINDS, which is also an NIH institute for the past 5 years. And what we have done in this specific project is to develop methods to facilitate medication titration in late-stage Parkinson's disease. Everybody, unfortunately, is familiar with Parkinson's disease. This is a very common neurological condition. I think it's about, I think we have about 200 people here. Well, let's say 200 just to make it simple, right? Unfortunately, when we will be above 65 years old, 6 of us will have Parkinson's disease. This is just the reality. So unfortunately, this is a very common disease. About